system that's basically, yeah, there we go. And we're being recorded. So what you need to know about Kubernetes is basically that it's a managed system for running workloads that are highly scalable and highly available. So as far as actually operating Kubernetes goes, you can spin up Kubernetes clusters yourself and do it on bare metal instances, or you can use a managed offering from a cloud provider. And what we're going to do here today is we're going to use the AWS managed offering, which is EKS, the Elastic Kubernetes Service. The other thing that's somewhat important to note about the tools that we're looking at here is we're looking at 4 different tools. We're going to look at Checkov, which is an infrastructure as code scanning tool. The Sonar Cube, which is used for scanning your actual application code. And Kubernetes, which is used for benchmarking your cluster, and Falco, which is used for runtime security on your cluster. So the important thing to take away into the workplace is that even if you don't use Kubernetes, Kubernetes and Falco are tools that are specific to Kubernetes, but Checkov and Sonar Cube are not. It's just that the way that we're configuring them is basically the way that we're configuring them is tailored to Kubernetes, and we're using them for Kubernetes workloads. Once we get to the point of actually going through here, I will explain sort of some of the benefits and downsides of the Kubernetes ecosystem and that way of doing it, in my view. But we will see how we go with that. So Kubernetes is pretty popular. A lot of places are using it. You'll find a lot of, a lot of job ads these days are all about the Kubernetes. So these are useful skills to have. Even if it's not something that you work with now, you'll probably end up working with it in the future. And so the first thing that we have to actually do here is to spin up a Kubernetes cluster that we can test with. And there are a few bits of infrastructure, and I need to remember to open everything in a new tab, that we need to set up before we can do that. So if you're following along and you're running this in your own setup, the first thing that we need to do is to actually create ourselves a key pair. And that is going to be used when we create the worker nodes. That if we want to SSH into the worker nodes to see what's going on, which we're probably not going to do, but it's required by AWS, we would use that key pair to do it. So I've already created one in advance, but the key pair, basically the dialog that you're looking at here is this one. You want to use the default, so RSA, I think private key file format doesn't really matter. If you're using Windows PuTTY, it's PPK. If you're using a Unix-based system, the .pem is what you want. And you can enter whatever key pair name you want here. Once you click create, it will allow you to download that key pair onto your machine. So I believe that you can create those key pairs using CloudFormation, but in terms of some of the setup that we have to do here, there is a little bit that we'll do manually, just so that you can see how it actually works. Then we have to look at spinning up the actual Kubernetes cluster. And this is the bit that is going to cost us a bit of money, because in AWS, the Kubernetes control plane costs you, I think it's about 25 Australian cents an hour to run. And the worker nodes that we're going to set up also cost money, which is where we get the figure of about $1 to $2 an hour from. And in terms of spinning up the Kubernetes cluster, I am not going to make you go in and do it manually. I've actually provided some templates. And if you want to see how the templates work, you can actually have a look in this templates folder. You can bring them up and you can see what they're actually doing. But for the purposes of this, the worker nodes template we will have to deploy manually. But if you're following along, the first thing that you want to do is click on that link, the control plane link, and then CloudFormation will basically provide us with an interface, which is a quick create for this CloudFormation stack to actually spin it up in our account. And the stack name we don't want to change. We should be relatively comfortable with all of the defaults here, because they've been set up appropriately and they've been set up so that we won't end up with any clashes with Cloud9 when we spin that up. This template will create an IAM resource, and that's because we need to set up an IAM role to actually create the control plane on the cluster. And we need to attach that to our Cloud9 instance so that we'll have access to do things with the control plane later on. So you do want to acknowledge that. That's fine. We know that it's going to create IAM resources. They're very limited in scope. And then you click create stack. Now, the other thing that's worth noting about this workshop is that, yep.
There's a question asking about sharing info on Kubernetes, user authentication, etc. Here.
Okay, so I can, there are certainly resources on things like Kubernetes user authentication that I can go and dig up. This workshop doesn't really cover that. And the reason why we're not covering that in this workshop is because if you look at a lot of the tutorials, they will actually, tutorials on how to secure your Kubernetes cluster, they will actually talk about that as something that you should do standard. The way that you would generally do that is with something called role-based access control, or RBAC. And particularly if you're using a managed cloud offering, something like AWS EKS or GKE or AKS, which are the Google and Azure equivalents, often what you can actually do is, particularly if you have SSO set up for your cloud provider, you can actually map people's AWS login to the EKS login on their cluster. So you don't have people then logging in with the admin file and they'll have admin permissions for everything. You configure their permissions within AWS to basically say, we want you to be able to access, this set of resources and this set of resources, but we don't necessarily want you to be able to, have admin permissions, or we want you to just have read only on the cluster so you can go in and get all of the logs, but we don't want you to be able to deploy things because that should be done through pipelines. That's all something that you can do with role-based access control. And the really nice thing about doing it, all of that and using a managed Kubernetes stack like EKS is that it just abstracts it all away. So you basically make the cloud provider do it for you. So as far as the user authentication piece, I'd recommend going and looking that up if you are setting it up for a Kubernetes cluster. The standard recommendation is that you use role-based access control. That's possibly actually a topic for a future workshop, is one of the less obscure aspects of security on Kubernetes. So while the control plane here is spinning up, this CloudFormation stack is actually going to take quite a lot of time to deploy. I've had it go between 15 and 25 minutes to deploy all of the resources that we need. The good news is that while that's happening, we can go and set up a couple of other things that we are going to use during the process of this lab. And the first one here is Cloud9. Those of you who are regular participants at AWS Programming and Tools might well remember Cloud9. It's an interactive IDE that's provided by AWS. We use it for a lot of our labs. And the reason why we're going to spin up Cloud9 here is because it comes with a lot of tools already installed, and it allows us a standard environment so that, we don't have to worry about doing a huge amount of debugging. We don't have to worry about doing a huge amount of debugging if we end up with unexpected error messages as we're spinning things up. So I have a nice little link to our predefined CloudFormation template to spin up Cloud9. You can find that one in the templates folder as well, just all the way up here, the obscure security Cloud9 file if you want to see what you're deploying. And this one, we don't have parameters, so we can just click the create button on it. Now this one should be much quicker. It will deploy 2 different CloudFormation stacks. It'll deploy the one with all of the networking resources. Then it'll deploy a second one, which is basically just the CloudFormation stack for the Cloud9 instance itself that spins up all of the information that that needs. And once that's run, yeah, we'll see 2 stacks in the create complete state. So these 2 are going to take a minute to run. If you have any more general questions about Kubernetes or things that you would like to know, now would be a very good time to throw them at me before we sort of get into the bulk of this workshop. And I can see we actually have a broken link there, but that's fine. I'll put the link in the chat. So yeah, here we're basically just going to be doing a bit of waiting for all of this to actually finish spinning itself up. Kubernetes, in terms of the way that it's actually set up, is it's very extensive. Yeah, so as far as what we're spinning up using CloudFormation, we're just going to do the Cloud9 instance in the control plane. I'll walk you through how to do the node setup manually, and I am going to come back to this and make sure that I work out what the problem is and I fix it. Either I deleted something that I shouldn't have deleted, or there's something in the new Amazon Linux AMI that's messed up the networking. But if you do want to look at, while we've got this going, we can actually have a look at what it is that we're deploying. So if we open up the EKS control, yep.
There's another question on the chat from Ari. He's asking
about the templates. I've just answered that.
Oh, excellent. Sorry.
I just said that we're not going to use the worker nodes template because there's an issue with it. But these other 2 templates we should have going. So our Cloud9 instance is complete. Before we go and actually hook that up, we can have a look at the whole components that we've got in here to actually configure the Kubernetes cluster. So we've got some IP blocks, 1 for a VPC and 4 for different subnets within that VPC. We've got metadata on the interface, which is again those parameters. Then we spin up the Iam role, and this is just the one that allows us to actually interact with the cluster. So that's what we're using to create the cluster. That's what we're going to attach to Cloud9 so that we can actually run commands on the cluster control plane. And so this instance profile here is something that you may not necessarily have encountered before, particularly if you've not worked with Kubernetes. That's basically taking this Iam role and putting it in a way that EC2 can parse. My use of it here is slightly cheaty. And then we have, if you're familiar with EC2, we have a lot of the sort of standard networking resources that you would expect. A VPC, an internet gateway, we're attaching all of that. We've got route tables to direct the traffic. We've got NAT gateways. We've got elastic IPs that are attached to those. We're creating our 2 public subnets, our 2 private subnets, route table associations with all of those. And then we create the actual control plane. And this is very simple. It's not, the control plane is not an EC2 instance in and of itself. If you go into EC2, you don't see it. It's all managed within EKS itself. So let's now go and we will hook up. So where you want to be to do this is the Ec2 Console, which we'll just open in the new tab. Just in case anyone is running workloads in different regions, the stacks here are deploying into US West 2, which is in Oregon. The reason why I've done that is a lot of people, you know, if you've got your own AWS account, you're probably running things in US East 1 or Sydney AP Southeast 2. So we're deploying here to a region that's fairly low cost, but it's also one that you're not likely to be using yourselves. And so we can see here, when we go in and have a look at the actual instance, you know, the EC2 instances console, we've got this AWS Cloud9 Workshop Cloud9 instance running. And so we're going to jump down to security and modify the Iam Role. And this is going to allow us to manually attach the instance profile that we created in our CloudFormation template, which basically means that our Cloud9 instance, which is what we're going to use for a bunch of the work that we're doing here. Apparently my old, the instance that I had running before that I terminated is still sitting around, but that's the one that I was using for testing. So we're going to attach that profile, and then that basically means that when we're hitting our stacks, our EKS cluster from the Cloud9 IDE, we are then going to be able to interact with it because we've got the permissions to do so. So jump into Cloud9 using the link under setting up a Cloud9 environment, the Cloud9 management page, and you can open up the IDE down here. And that will take a minute to load. And then what we are going to do is we are going to check out, once this finishes starting up, we are going to check out the code for this workshop. Oh yes, I'd forgotten that it's another thing that GitHub did in the middle of me setting up this repository is they obsoleted SSH. So we need to use an HTTPS link. I'll just copy that git clone and put it in the chat as well. And I will, I'll fix that one in the repository itself later. And the HTTPS link will work because the repo is public. So now if we have a look at the obscure security folder in here, what we've done is we've cloned the entire repository in. And this is now going to matter for the first one of these obscure security tools that we're looking at, which is Chekhov. And so Chekhov is open source. And what it basically is it's, if you've ever encountered tools like Claire, which are used to scan Docker images for security vulnerabilities, Chekhov does that, but it does that for infrastructure as code. And the reason why Chekhov is the tool that we're demonstrating here is because it doesn't just do CloudFormation. So if you work in an organization that has multi-cloud, I know it does ARM templates. I don't know if it does the Google Cloud equivalent, but you can use it to scan Terraform. You can use it to scan like Kubernetes YAML files that you would use to deploy Kubernetes workloads, and you can use it to scan Docker files. So this is a really good little tool. It's open source, it's free. And what we are going to do, now that we have these wonderful files, these CloudFormation files that we have set up with our Kubernetes cluster, is we're going to see if they have any security vulnerabilities. So on your Cloud9 instance, if you're not using Cloud9, this could be somewhere that you're going to run into issues because Chekhov requires Python 3.7 to run. And a lot of systems, particularly macOS, so Darwin systems, will ship with a much earlier version of Python than that. But if you're in the Cloud9 instance, we should just be able to run a pip3 install Chekhov. And that is going to run. That will pull down a bunch of information for us. And once it is done with that, we will have the Chekhov tool installed. And part of the beauty of Chekhov is actually scanning files with it is really, really simple. So it's to look at the files that we've used to set up our Cloud9 instance and that we've used to set up our EKS cluster. This is the command that you want. And basically all that is it's a Chekhov run in the directory in the root of our Cloud9, obscure security, and step 0 templates. And as you can see on the Cloud9 instance, we've actually got the 3 files in here. Now, that was quite quick. And if we we'll just open this, bring up a little more of this on the page. And you can see here, you know, it prints out a nice scan result. And so this is benchmarking against, some of it is, you know, benchmarks against best practices. Some of these are dictated a bit by the people who actually created Chekhov, but in general, I have found them to be very sensible. And so we can see here, as a result of that scan report, we have run 36 checks, 34 of them passed, and 2 of them failed. And if we look at, you know, a lot of these are fairly standard checks. So we're checking on Iam roles to make sure that we're not giving them too many permissions. We're checking on security groups to make sure that they're not open to the internet. We're checking on, again, IAM roles. And a lot of this is IAM roles and security groups. And then we hit the 2 checks that actually failed. And these failed quite intentionally because the AWS templates that I chose to use ones that were not particularly secure. And again, if you look at a lot of these common guides on how you do Kubernetes security, secrets encryption on the cluster is something that is going to come up a hell of a lot of the time. It's a really common way that people mess up Kubernetes clusters, because that basically the Cicd folder, which is where Kubernetes stores all of its secrets, by default in a Kubernetes cluster, that's not actually encrypted. So you have to go and say to Kubernetes, hey, I want you to encrypt this. If it's not encrypted, anyone who can get into the cluster can just go in, write out the contents of that directory, and they have all of your secrets, which is not particularly good. The other issue that we've run into is one that's actually in the node group. And that is that when you create a node group using AWS EKS, you get a launch configuration volume that's created, an EBS volume that's created. And that sort of explains, you know, what we're spinning up, how everything is set up. And again, because there can potentially be secrets in that data, and there can potentially be things like SSH keys that you would use to actually get onto the nodes themselves, that's another thing that you want to encrypt. So another thing that's quite nice about Chekhov is that if we click on any of these links, it's not quite what I wanted to do because I keep forgetting that I'm not on my own machine. Can we also remediate these CKVs? I'll get to that in a minute. We'll have a look at the documentation first, and then we'll get to what you can do with Chekhov in terms of automation. There's not quite as much as maybe you'd want, but there's certainly quite a bit that you can do. So what we can do here is, if you bring up the documentation pages that Bridge crew, who are the people who create Chekhov, actually give you, they will give you a description of the issue that you've run into. So here, you know, secrets in Kubernetes enables managing sensitive information such as passwords and API keys using Kubernetes native APIs. When creating a secret resource, the Kubernetes API server stores it in Cicd in a base64 encoded form. For example, using kubectl create secret. And for people who aren't familiar with Kubernetes, we'll get to kubectl in a minute as well. EKS can encrypt etc.d volumes at disk level using AWS managed encryption keys. And then it will talk about things like the security best practice. And so in this case, the security best practice is using envelope encryption. So you would encrypt a key with another key. But what we're doing here is a bit more basic than that. We're literally just storing it as base 64 encoded. And so the nice thing that will happen here is you'll actually get instructions. And here they're not as extensive. For the other vulnerability, they're a bit more extensive. But you'll get instructions on how you can actually remediate those issues in whatever cloud provider you're using. So here, if we want to go into our control plane file and actually fix this, what we are looking for is the AWS EKS cluster resource, and then the properties encryption config resources secrets is going to be the argument. And that little plus is the line that we need to add. So what's going on at the moment, we don't actually have any encryption configurations in that EKS cluster, so nothing is being encrypted when we create it. So what we're going to do is we're just going to grab that little bit of code and then jump back over to Cloud9, and then we can actually open the EKS control plane file, and we can go and modify this on the fly. So we're jumping down here. We've got properties name, role on, we've got the resources that have been set up in the VPC, and then we're just going to add in here an encryption config, and then we are encrypting the secrets resource. And then we're going to save that file, because in a minute what we'll do is we'll run the scan again, and we will actually see what has been, we'll run the scan again and we'll make sure that it's been resolved. And then the other security vulnerability that we were notified of here was the one in the node group, which was that on the launch configuration volume, we're not actually encrypting that. And again, you've got a good explanation here of, there's data stored on the volume, snapshots that you create from the volume, but there's also data in transit between EBS and EC2 is encrypted. And yeah, often those EBS volumes do store information like SSH keys. So I believe there's some degree of protection built into Kubernetes itself to try to stop you from writing that out. But it is a good thing to do to actually go in and fix that. And so here we've got a few different fixes. We've got a runtime fix where you would actually go into the AWS console and you would click at this, or you would use a CLI command to resolve it. But what we are interested in is, again, fixing it in our template. And so we're looking then here in the launch configuration at the block device mappings. And the one that we're worried about encrypting is this /dev/SDK. So we're going to grab the encrypted true line here. And again, jump back to Cloud9 instance, bring up the node group file. And all the way down here, we are looking at the node launch config. And we've got the devxvda, which is the one where we have the issue. We've got some EBS configurations in there already. The delete on termination means that once we spin everything down, it gets deleted. We've got a volume size, which is configurable in the template. And so we're just going to stick in here that that is encrypted. And now let's actually take this for another test drive and try rerunning Chekhov to see what happens. So we're just going to run this again. And what we find here is that looks like a whole lot of green. And we can see the two issues that were on our checklist. One of them is down the bottom here. The ensuring that all data stored in the launch configuration EBS is securely encrypted. And then if we jump up a little bit here, we will have the same for the control plane. Yep, ensuring that the cluster itself has secrets encryption enabled. And now we've got 36 pass checks. So this is a good sign. And you can see from that, using Chekhov to remediate these sorts of security issues is actually really easy. And it's very intuitive because they'll often give you documentation on how to resolve it. Now, in terms of automation, there are a few things that we can do with this. So as you can see here, we've actually gone in and installed Chekhov as a tool on a Cloud9 instance. And that's just as a proof of concept that, yes, we can actually scan these Kubernetes configuration files and we can see any issues as we're going. And yes, Andrew, you are correct. This is just looking at the static configuration. Live resources are the next thing that we're going to get to. We'll run through a couple of different ways that you can look at that. But the way that you can use these static scanning tools like Chekhov really effectively is if you do things like actually integrating them into your pipeline. So just bring up the question about automation again. Yeah, so auto remediating. In terms of auto remediating the vulnerabilities, that's a little bit harder to do because you have to build up a lot of infrastructure around that. I believe that there are potentially tools out there that will allow you to do it, but I find that a lot of utility around automating the use of tools like this is actually just putting a block in the pipeline to say, hey, your stuff is insecure. What we want you to do here is we want you to think about it. So for example, what you could do is if you have, say, an infrastructure repository that's used, or even a repository for a single service that has AWS infrastructure that's defining CloudFormation or Terraform in it, as part of your pipeline, you can actually install Chekhov on the nodes for whatever the agents for whatever sort of pipelining tool you use, whether that be a build kite or a Jenkins, or if you're using something like GitHub Actions, which is hosted, you can actually install Chekhov as part of the pipeline itself. And then you basically just say, if anything fails, then stop the pipeline. I'm fairly sure that basically the way that it works is if anything fails, you get an error message on stood out. And so this first run here, if that had been in a pipeline, would have actually blocked itself. Don't quote me on that. It's been a bit of time since I last set this up in a pipeline, but it's certainly very possible to actually set up pipelines to block in a way that, if these tests fail, then you actually block the pipeline. In terms of extracting things as JSON or machine readable, I know that some of the other tools that are around do this. So you can actually extract the information you get from running these scans in a machine readable format. I believe Chekhov does as well. And so then if you wanted to import that to reporting, that would be fairly easy to do. Yeah, the return code is one, so it would fail. I'm pretty sure that that's the case. Well, you've observed, so Palab has observed that the use of inline Chekhov delays the build time significantly. Is there any way that we can improve it? That's something that I probably should be able to speak to, but can't. And that's partly for the reason that a lot of the build pipelines that I deal with on a regular basis are either really, really fast or really, really slow. And so that's partly an artifact of, either you deal with a big monolith repository that's got a whole bunch of infrastructure code in it, or if you're dealing with perhaps really small services, there's not a lot to scan. So in answer to the question about delay of the build time, I'm not actually sure. It might be a case of just throwing more compute resources at it. It might also be a case of being selective about what you're scanning, or trying to configure Chekhov so that it's running, a more limited set of the scans that it typically runs. It is a very configurable tool, so you can just tell it to ignore certain scans. And if that's sort of what you want to do in terms of how you configure your environment, that is not necessarily a bad way to do it. But in terms of delaying the build time, I've not really had a chance to work with it on large enough workloads, you know, or workloads at that kind of middling size where I would notice enough to really play around with it. I'm sure there are ways to improve it, but it might also be something where, you know, there might be other tools that are quicker, or it might be an acceptable trade-off for improved security. So that's probably what to note about that. And yeah, in terms of exporting it as machine readable information, I know that other similar tools have the ability to configure exporting as machine readable in the way that you know, Chekhov may or may not, but I'd have to go and check on that, because every time that I've integrated it into a build pipeline, the way that I've basically set it up is just that if it fails, it stops the build pipeline. And then at that point, you know, potentially you do actually want a human to look at it anyway, rather than trying to automate it as you go, so that whoever's made those infrastructure changes is aware that there are potentially security issues. And that can be the danger a bit with over automating things, is sometimes if you automate too much, people don't actually learn, and they don't realize when they're doing things in a way that's not optimal, or maybe a way that's actually failing security checks. So sometimes it is good to sort of force that manual intervention to actually make people really think about the code that they develop. But I'm sure that if you wanted to automate it, there are ways to do it. So that's roughly it for Chekhov. The next tool that we're going to look at is a tool called Kubebench. And in order to actually set up and run Kubebench, first of all, we're actually going to go into this, the obscure security cluster, and we are going to create nodes, which I know you can do. I know that you can do this somewhere in here, and I've forgotten where it is. There we go. So we're going to add a node group. So we're going to need to manually create the Iam role for that. And in order to do that, I'm just going to grab from the CloudFormation template. And this is kind of a lesson in why you want to do things with CloudFormation as much as you possibly can, because it is often much easier to set stuff up in a repeatable, configurable way if you possibly can. So we're going to create an Iam role. And we are looking here at the AWS service. Somewhere here that there is an option for EKS. And so what we want here is the node group role. And I think what we want is actually going to be very close to the default. Yeah, so this will probably be fairly close to what we need. So we're just going to attach that. And now if we go back to EKS and we refresh this here, once the role actually gets created, we should have the ability to use it. This is a lesson why you don't click on things. Anyway, if we look at the other things that you need to do when you create a node group, you need to obviously assign it a name. So going to call this one the obscure security node group. We are not going to use a launch template. So labels and taints, basically Kubernetes taints and labels are designators that you can attach to the nodes, which are the underlying infrastructure that actually runs your Kubernetes. runs your Kubernetes cluster to basically say, I want to schedule these types of workloads on these particular nodes. So if you wanted to separate, say, applications and tooling, that's something that you can do with nodes. You might also separate nodes by, if you have a lot of, say, machine learning work that you're doing, which needs particularly compute power, you might actually set up compute nodes that are configured differently. Or, if you have a process that doesn't do much work but uses quite a lot of storage, you might set up memory optimized nodes that are designed for that. So you can kind of set up, you can actually set up different underlying hardware to run different Kubernetes workloads, and the labels and the taints are what you use to split those apart. So the taints are basically a don't schedule workloads on nodes that have this taint. The labels are, encouragement to schedule workloads, I believe, on the node group that has the label. I've historically used taints more than labels. Now I suspect that this is going to, get grumpy with me. So in the meantime, let's actually jump into the next section and look at, while I'm trying to work out the issue with this, the tool we're going to be installing to actually run security benchmarks on the cluster is a tool called Kubebench. And so for reference in talking about the static versus dynamic, this tool is the dynamic equivalent of Chekhov, basically. So Chekhov is the static security analysis tool, or the static application security tool. I can't remember what the buzzword they use for it is, but Chekhov is the tool that you're running on your infrastructure as code that's already defined. Once you've set it up, Kubebench is what you run to make sure that you're actually doing what you think you're doing. So in order to manage this, there are a couple of things that we need to do. And the first one in Cloud9 is we need to install kubectl, which is the tool that you would typically use to manage Kubernetes workloads. As far as I can tell, it's not in the Amazon Linux or the Red Hat package managers. So we're going to follow the AWS documentation and install it from source. The reason why we're using sudo here, if you have a look at the instructions, is because we need it to be able to run chmod on files that are in the bin directory. But this /usr/bin is where a lot of the command line tools that you would use if you're using Linux day-to-day actually end up on the system. That's been changed. Exit will take us out of sudo mode, and then we can grab this command, and that's going to tell us that we're using kubectl version 1.20, which is appropriate because the EKS cluster that we've deployed is also using version 1.20. Now, I am going to attempt to work out Iam roles here. It may be that we need to actually create the instance profile as well. But I am admittedly not 100% sure about this. And again, this is why you don't click ops things. It's the advantage of setting these things up properly in CloudFormation. What we may need to do is to actually create a custom policy. So if we jump into IAM policies, what we're looking at here in terms of what we want to actually create is we want to go and create a role that has some specific AWS managed policies attached to it. And so we've got the EC2 container registry read-only, which is basically giving it read-only access to EC2. And these other two policies are around getting EKS to actually manage the worker nodes. The other issue that we may run into here is this is all defined using YAML, and I don't think the JSON editor will actually take YAML. But let's see if I can plug this in here and actually edit it in a way that's going to work for this. So we have version, we have the statement. Okay, what we should be able to do is actually import the 3 managed policies that we're looking at here. And so it's the EKS worker node policy is 1. Yes, which doesn't like me because I've created errors in the JSON. Let's try that again. And EKS in particular is one thing where I would recommend doing it with CloudFormation if you possibly can. This was a tool that was not ever designed to be used manually. One thing that you find with a lot of organizations that have run Kubernetes on AWS is AWS actually came to the party on Kubernetes really late. So both Google and Azure, even IBM Cloud, actually had managed Kubernetes offerings well before Amazon did. Amazon only came to the party in mid-2018. So what you'll find is a lot of companies that actually run EKS in the day-to-day or run Kubernetes on AWS in the day-to-day is particularly if they have legacy infrastructure, they're doing that on bare metal EC2 instances and they're managing it themselves. If you get the chance, I would definitely recommend migrate to EKS, migrate to CloudFormation. Now, my suspicion here is that what AWS tells us that it's looking for, which is what my suspicion is that what AWS tells us that it's looking for might not actually be what it's looking for. So I think what I'm going to do here, so that we don't end up spending too much time on this, is I'm actually going to take that role and we're going to deploy in CloudFormation. We're going to deploy a cut down version of the CloudFormation stack that just creates that role. This is another nice thing about CloudFormation stacks, is you can kind of pick and choose what you want to create. So we're going to create a template. Want to upload a file. I'm just going to quickly open my code editor in order to cut this down. So I'll have to drop the screen share and switch the screen that I'm sharing so that you can all see that. So what I'm going to do is I'm basically just going to grab the node group template here. We're going to get rid of quite a lot of it. And what we're looking for is the resources around those roles. The node instance role, the node instance profile. We are going to, we do want to keep the node instance role in outputs. And then save that file. Jump back then to AWS, and we should be able to upload that here. That's not where I want to be. I should be able to drag and drop that. Here we go. All right. So then we need to give it a stack name. So we're going to call this the obscure security node group role. We don't have parameters because we're just deploying that. And we're going to hit the next button to deploy. I know that CloudFormation is going to create IAM resources. And then that one is just going to sit there in progress. And hopefully that will give us the role to actually be able to spin up the worker nodes. But in the meantime, what we will then do in order to set up kubectl so that it can talk to the Kubernetes cluster, the control plane of the cluster that we have spun up, we need to actually create a kubeconfig file, and that basically tells the workloads that we are working with, the kubectl basically on the Cloud9 end, where it needs to go in order to find the credentials for the cluster that we're looking at. So if you copy this command and we just stick that into Cloud9 here, then you can see we've got this message, added new context to home/ec2 user/.cube/config. And that, if that is your root directory, that .cube/config is the standard directory where all of your kubeconfig files will be. And generally the way that it works, this is actually just one flat file where you can have configurations for a whole lot of different clusters. And if you operate with multiple EKS clusters, there are actually ways to manage that. So now that we've got this configured, let's clone the KubeBench repository as well while we're going. And that one was HTTPS. So what we're cloning in here is the repository for the KubeBench tool. And they actually have in there a job.yaml. And we're going to use that job. We're going to run that job.yaml against our cluster, basically to see what we get in terms of runtime information. But now that kubectl is set up, we can run commands to actually see what's going on the cluster. You can tell that I didn't test this in Cloud9. That is mildly concerning. When I originally did this, I did it in EKS, but I tested it on my local machine and I was logged into my AWS account. So the interesting thing about this though is because the Cloud9 instance and the EKS cluster are in the same network, attaching the role should be enough to get us into kubectl, and I believe it was earlier, but clearly no plans for my first contact with the enemy today. So let's see if we can actually get the node group spun up. If we can't, then probably what I'll have to do is go back and attack this later. But I can talk everyone through how these three other tools that we're looking at work. And the instructions are basically there if you want to go away and test them out, if you've got your own Kubernetes cluster, and I'll go away and try and fix some of these issues as well. But the positive is we do actually have that instance role configured correctly. So we can create ourselves an obscure security node group. We're not going to use a launch template. We don't need labels, taints, or tags. I don't really want to use the Amazon Linux 2 AMI because that's the one that broke on me, but okay, let's try it. The instance types are T3 medium is fairly standard if you're running sort of your own workloads. That's what a lot of the tests, if you see example CloudFormation templates out there, a lot of them will use T3 mediums for the worker nodes because they're big enough that you can play around on them without running out of memory, but not so big that they're going to completely break your wallet if you keep them running for too long. And what we actually want here is a group with a minimum size of 2 nodes and a maximum size of 4 nodes, a desired size of 2 nodes. I think the configuration we were running with before had 3, but as long as you can replicate a lot of these workloads, 2 is going to be fairly sufficient here. The maximum amount available is basically your tolerance for having nodes offline. And so here we're going to say that it's 1, because effectively when you update the node group, Kubernetes actually has to take them offline before it can bring new ones online. You know, if you're running 10 or 20 nodes, your tolerance here may actually be higher. And these are the 4 subnets that we want to use, which is being configured through networking. And then we can go ahead and we can actually create the node group. And theoretically, once that creates, that will allow us to run workloads on EKS. In practice, apparently, Cloud9 has decided otherwise. I might see if I can get this running on my system so that I can demonstrate how it works. But in the meantime, while those nodes are creating, in terms of how Kubebench actually works, there are a couple of different ways of doing it. But the one that's sort of recommended is that you actually install as a job on your cluster, because it will then run from within the cluster. It has access to most of what it needs, and you can get the output of that job just by basically running kubectl get pods to find the pod name, and then you can just run this command and that will spit out the logs of it. And so what that will tell you is, you know, here are the runtime security issues that you have with your cluster in terms of, you know, we're looking at common CVEs. And if you actually manage to get this working, what you find is that the 2 issues that you run into, the 2 main ones are actually the same 2 that Chekhov picked up, which is really nice because it means if you run both tools, you can sort of validate. So you know, you can use Chekhov on tools other than Kubernetes, but if you do use Kubebench, you can actually sort of validate the output of a lot of those static security tools. So, you know, maybe you run the static security, you run all of your infrastructure through the static security tool at first, and that will tell you that there are a bunch of issues. Then Kubebench will give you a bit more specificity in terms of, you know, how severe are these issues. If you go and look at their the repository for it, actually a lot of the documentation for Kubebench is in the repository, and there are several different things that it will allow you to do. So you can actually get, I'm unsure whether you can get machine readable config out of this, because my take on it has always been put this in front of people. You know, if you're going to run tools like this, I tend to sort of go with the approach of you actually put it in front of a human and you say, hey, here are all the issues, can we work on remediating them so that people are learning? But what you can do here is, this uses the Center for Information Security's Kubernetes benchmark, which is the fairly standard benchmark that pretty well everyone will use in terms of, you know, is your cluster up to scratch in the way that it's configured. And so with Kubernetes, you can actually configure it. There's documentation in here that will explain how you configure it using YAML files. And you can basically configure that so it's like, if there are particular aspects of Kubernetes where you've had a lot of issues, like the API server is one where you'll get a lot that will come up because the Kubernetes API isn't exactly secure by default. The failing to encrypt, etc. D usually ends up being, you know, massive warning massive warning sirens when you're not doing that, because it really is critical. But if you discovered that you had, say, a lot more issues, with the way that the API server was configured, that's something where you can actually then configure Kubebench to basically just go, all right, give me this section of the report. Or, if you have, say, the Kubernetes API structure in terms of talking about speeding things up, if you want to run Kubebench on a regular basis and you have, different teams that handle different bits of it, or you can configure Kubebench so that you're only running it against the sections that you deem to be really critical. So you might want to be checking on things like, again, that is all of our secrets and all of our critical data encrypted. But you might not be quite so concerned about things like the Kubernetes API. If your Kubernetes cluster is private, there's a bunch of stuff around external access that you might not be super concerned with. Or if you have a bunch of workloads that should all talk with each other, there will be some recommendations in there that end up being not super applicable to you. So the other two tools that we're looking at, that I sort of wanted to look at here, and I think it's probably going to be more valuable if I talk through it than actually try to demo these, considering that EKS has fallen over on me, are Sonar Cube and Falco. So Sonar Cube is a really hard one to test when it's on a Kubernetes cluster. But this kind of comes back to some of the benefits and drawbacks of why you use Kubernetes in the first place. Because if you go away and you configure Sonar Cube yourself, it's a massive pain to, there's a cloud hosted offering, but if you were to run it on an EC2 instance somewhere, it's a massive pain to actually set this up. So one of the advantages of using container orchestration like Kubernetes is a lot of these providers have already done it for you. And what you can see here is there's a provider that produces a Helm chart Sonar Cube. And Helm is something that we can look at because we can run that on Cloud9. So let's actually download Helm and we can kind of see what it does. So this is a tool that you can use to automatically install Kubernetes workloads and to make sure that they are giving you what you expect they would. So you can deploy workloads directly on Kubernetes using Kubernetes deployments files, but Helm kind of creates a consistent wrapper around that. And so a lot of organizations will use it. And the really nice thing about Helm is, for a lot of these tools, you can actually just go and grab yourself a Helm chart. So Helm will allow you to configure, if you go and look at the actual documentation for this Helm chart, is eminently configurable. There's quite a lot that you can do with it. You can do things like change the type of database that backs Sonar Cube. You can change, the amount of memory that you're giving it and things like that. But the advantage of this is that if you deploy Helm using Sonar Cube or Sonar Cube using Helm, you don't have to do the work of setting up the infrastructure yourself. And in terms of testing it on example code, one thing that you need to do here, and it's worth looking through the documentation for explanation on how to do it, is if you have, say, your code hosted in GitHub, or you've got, you're using Kubernetes, but you're using a build kite or a GitHub Actions or something where a lot of that, that's running elsewhere. So you're downloading the code elsewhere. One thing that you need to actually do is set up an ingress so that you can basically, your Sonar Cube is publicly available on the same IP address or URL as your Kubernetes cluster is. So as long as you're authenticated, you can then push information up and have Sonar Cube actually scan through it. But the other disadvantage that you find, right, the trade-off for it being super easy to actually spin stuff like Sonar Cube up is that there are some limitations because it wasn't originally designed to run on Kubernetes. The one that I want to spend the rest of the time on, because configuring Falco is really interesting, and that's something else that we can do together, is Falco. And so Falco is half Kuberbench and half, some sort of a DDoS protection tool, probably closer to guard duty actually, and it runs all the time. So the way that it's sort of built is it's a runtime security tool, and what that means is it's constantly scanning for threats. So you can configure Falco that if something somehow gets past Chekhov, or it gets past whatever scanning you're using for Helm, and you deploy a workload that's incorrectly configured, Falco can just turn it off for you. And the other thing that it will do is it will notify you of abnormal patterns of external access. So again, you've got a public Helm chart, you can deploy it onto the cluster. But what's more interesting here with Falco is the process of actually building the files that you use to tell it what you want it to do. And so we have a bunch of information here about the Falco rules and the Falco conditions. And where we want to start is looking at sort of how the files break down. So when you install Falco itself, it actually installs a default rules file, and that gives you a predefined set of rules. But you can reconfigure it so that you can set up, your own local rules file, which you can then push up to a cluster. And that will give you the ability to say, maybe I don't want to be as strict on security in certain aspects, or maybe I do. And yeah, I believe that the recording of the stream will be released later, and the list of tools is on the in the GitHub repo. Yeah. But effectively what you can do here is you can basically say to Falco, I don't like your defaults. Either I want to be stricter or I want to be less strict. So I'm going to go in and change things in the local rules file. And so the important thing to understand here, because the thing with Falco is it's a really valuable tool, but understanding how to configure it well is actually a super dense topic. So we have, you can see the list of fields that can be used in terms of setting up conditions. And so what you're looking at here is the FD is the group of rules that deals with, not actually sure what a good description of this is, but it's looking at things like files. It also looks at things like networking. So if you wanted to run scans against files and directories, this is the set of rules that you would use. And common ones that you're going to be calling out there, you potentially want to know file paths, you'll want to know directories, you'll potentially want to know whether something is a file or a directory. And something else that is interesting to note with files is when you're talking about files that are installed on the Kubernetes system, they belong to containers. This one is actually in understanding where issues with workloads that I've run into before. This piece of documentation and kind of playing around with setting up Falco rules files myself was actually really interesting in terms of that, because I did not realize, the standard process is to not write stuff out into the Kubernetes system. But if you set up Falco, so, you have, say, a workload that's outputting massive amounts of stuff into the Kubernetes file system and it's crashing the nodes, you can use fields like the container name to actually get out, where those files belong to, and you can use that basically to trace back the workloads. Then you're looking at things like processes and threads. So this is, basically about how information is being generated. A lot of this is probably fairly straightforward. System call events are another one, and that's sort of in terms of the raw information that you've got where Kubernetes is actually telling you what's going on. And so if you had things like, someone's going in and crashing a bunch of pods, there's some workload again that's flowing through its memory allocation. And so it's actually crashing pods, and that's where those system call events will be sort of logged out. Falco will actually give you the ability to sort of see what's going on and to configure rules files to basically say, if we start seeing these particular types of system events, that's a big concern to us. And so you can then go and say, if we have these particular types of system events, perform particular operations. Like if pods are accessing files that they shouldn't be accessing, that's something that we're worried about. If sort of the pods themselves, the workloads are actually being shut down, that's also something that we're worried about, and we may want to sort of have constraints around that. So that's what you're looking at in terms of events. And that's basically the core of that is that's what the Kubernetes pods are doing. You can also find out about things like users executing events. Very useful if you want to find out who's been making changes to your cluster, or if people have been going in and maybe accessing fields or pulling fields that they shouldn't have been. And again, the group will be quite useful to you in terms of actually, like if you start to get in messages that are talking about, say, unauthorized access, the group will be very useful for you there. We have a question about whether Falco can be configured to check against the CIS benchmark. And that's another very interesting one, because what Falco is kind of doing is it looks at the sort of, when you get the standards that Falco runs, it's not exactly the CIS benchmark. It's what the Cloud Native Computing Foundation, who actually run Falco, believe to be reasonable defaults. And there are some things where it will check against the CIS benchmark, like in terms of are workloads properly configured. But there's this whole sort of wild west in terms of, what might look like unauthorized access to your cluster happening in runtime, where the CIS benchmark doesn't really cover that. And so it's a bit like Chekhov, what Chekhov does is quite closely aligned to the CIS benchmark, but in practice with a lot of these vendors, there's a little bit of it where they're kind of dictating it for you. And they're saying, this is what we want it to look like. So that's something to always be aware of with these kinds of tools. To be honest, it's one of the reasons why I probably wouldn't recommend that you run Falco unless you are doing some of that more basic stuff, like actually running regular scans with Kubebench, which does benchmark against the CIS Kubernetes benchmark, which is considered the standard. Because as you can see from this, what I'm sort of hoping to get across with exposing you to all of the information that you can run through Falco is, things like Chekhov and Sonar Cube and Kubebench are obscure in the sense that a lot of people don't use them. But tools like Falco and service meshes are another one, which I talked about in the sort of the talk that inspired this workshop, are really, really bulky, and sometimes they can cost you as much in engineering time as they can actually save you in, in remediating security issues, right? Because when you've got to configure Falco rules, it takes so much information that you ingest and that you're looking at if you're not using the defaults. And if you're pretty security conscious, you may not want to. Or if you want to allow your devs to do things that maybe the standard security rules don't want them to do, even then, like, it can be a lot of work to set up those configurations to that standard. And I've even seen that with tools like Chekhov, Sonar Cube, Claire, where people will actually go away and they will change the configuration on that tool. And then, you know, either they've got it way too strict, and so people are then having difficulty deploying things, like they've got it so strict that, you know, if you pull the default Alpine image, that's going to fail, or they've got it way too lax. And so at that point, the tool just becomes pointless. So actually working out how to use these tools effectively is a massive, you know, it's a massive investment in engineering time, really, to get this right. So you get from, you know, get through Falco Kubernetes metadata. And so that gives you things like pod names, deployment names, which will basically allow you to trace stuff back to a workload. The Mesosphere metadata I've never actually used for anything. And then you're looking at things like the audit events. And this is kind of part of the power of a tool like Falco, is you can actually look at things like seeing, you know, have we got a massive number of people who are being refused authorization onto the cluster, and why? So that could indicate things like you've potentially got a DDoS attack coming into the cluster. You know, you can look at things like target resources. Are you having a massive amount of traffic coming into a resource that you maybe wouldn't have expected before? And that might indicate something like you've got an endpoint that you didn't realize was public, that shouldn't be public, and someone's found it and is hitting it. And if you look at kind of certificate issuers, one thing that I learned about 12 months ago that is a really interesting thing to know if you're interested at all in security is the certificates that are issued for your domain name are actually public. There are ways to go away and search certificates that have been issued by certificate authorities for your domain name. And so that can often be enough to kind of give people a pointer to where the subdomains are. So the 4 security tools that we're looking at, and if we go back and have a look at the actual repository, Chekhov, which does infrastructure as code scanning, KubeBench, which basically runs a security benchmark on your cluster, Sonar Cube, which you use for, you know, scanning actual application code. And what we're looking at the moment is Falco, which is a tool that does runtime security and is extremely configurable and extremely complex to get right. And so you've got, you know, that's sort of your audit information that you can get back of what's actually going on the cluster. And then, you know, it alerts to a lot of the standard places. So you can get it to alert to standard output. You can get Falco to alert to a file. One thing that I would like to explore actually doing as a lab at some point is getting Falco to send alerts to an HTTPS endpoint. So you can actually send Falco alerts to a Lambda, which will then notify you, say that you have unauthorized intrusions going on Slack. That might be something that would make for a really interesting workshop at some point. And so again, you know, the format that it's using is fairly closely, it's YAML files that you use to configure it. And so basically you just stick in the YAML file, you say, you know, I want to send alerts to here. And you can see they have, you know, some examples for sending it to URLs. They have some examples for, yeah, and here you go. So you can actually do it directly to a Slack webhook. But if you wanted to do more advanced configuration with Falco, I've never actually set it up to really output anywhere because I've never used it in a production cluster. But actually manipulating Falco alert data with a Lambda is something that I think might be really interesting to do at some point. So I guess the important thing to learn about this is, in terms of obscure security, like, a lot of obscure security tools are obscure because people just don't know about them. And that's particularly the case for, things like infrastructure as code scanning. But then you have tools like Falco. And again, you've got things like service meshes, which are obscure not just in the sense that not a lot of people use them, but they're obscure in the sense that they're massively complex. And so understanding, I could probably do a whole day workshop on just Falco on its own. And so a lot of, so Christian wants to know about image scanning. And for image scanning in the past, the tool, there are a couple of different tools that you can use. Considering that everything here is open source, probably the one that I would have gone with would be Claire, in keeping with the open source theme. The reason why I haven't actually mentioned image scanning is because it's not particularly obscure, in the sense that now a lot of, the standard Kubernetes security guides are actually saying you need to do this. So a lot of the standard Kubernetes security guides now are saying, you need to scan your images with something like Claire, or you need to scan your images, you need to use the ECR, the Elastic Container Registry image scanner, before you deploy stuff to your Kubernetes cluster. Because if you don't do that, that's actually where a lot of the issues will tend to come in. And if you're asking me, I would say, although it's not included here, Claire is one of the two things that I would say is probably the tool you should actually absolutely be using. Chekhov is the other one, because between them, even though it's static scanning, the advantage of those static scanning tools is you can actually block misconfigurations in the pipeline. And Kubebench is definitely worth the time to set up and run a couple of times as well, because that's going to give you a really good idea. Obviously, not everything can be defined in a static configuration file. There are some things, even if you set up your CloudFormation file, there are some aspects of the way that Kubernetes and the Kubernetes control plane are configured that you would actually have to go in and change with kubectl with that command line utility. So probably those are the three that I would be setting up. The utility of Sonar Cube really depends on what kind of enterprise or organization you're running in. I will just grab the link to Claire, and I'll throw that in the chat as well, because it is that is another one where if you're not if you haven't done a huge amount of work on Kubernetes before and you want to sort of know where to start on this obscure security, Claire is the other one that's really worth doing. But it is one thing that has been positive is, as I've been going through and looking at a lot of, what's the recommendation in terms of Kubernetes security, image scanners are actually making it in there now. People are saying this is something you need to do. If you don't do this, misconfigurations are going to creep in. I think that there's personally, one of my big gripes with Kubernetes is I think there's a lot more that they could do around stuff like, secure by default. So things like actually encrypting those, encrypting the Ec2 directory, encrypting where all of the secrets are stored. But, hopefully at some point, some of those things will be fixed, and hopefully at some point, some of these tools will become less secure or less obscure, not less secure. I definitely don't want them to be less secure. Hopefully they'll become less obscure, because a lot of these sort of common quick start guides about what you should do will actually start recommending them. So from here, what I think is probably the best thing to do is we will clean up, because I'm conscious that I want to give people ample time, particularly if you've configured things manually. I want to give you ample time to actually clean things up to make sure that you don't get charged, because while the one...
Oh, hi, Heather, it's Kevin. How are you going? Too bad. I got a missed call from you.
I think we've got someone who's on the
I-
phone. Can someone mute?
Kevin McGarver.
I think I can't. Kevin, can you mute yourself? Thank you.
All right. So yeah, I'm conscious because, you know, the $1 to $2 that we would have in running it now is not necessarily a huge amount, but that's really interesting. Seems like it might actually be a problem with the AMIs if spinning it up manually didn't work either. But that's something that I'm going to have to go away and figure out later. So I do apologize for that. It all worked before we were ready to go last week. And my feeling is it's that image change. There's something in the way that things are configured with the image change that it doesn't like it and it's just blowing up. So what we're going to do is we'll go into EC2 and, okay, the instances haven't spun up either. So we did very well in terms of actually configuring a Kubernetes cluster. So then basically everything that we're looking at will be in CloudFormation. And the nice thing about using these CloudFormation stacks is that all we need to do is go through and actually delete each of the stacks. So we can delete the node group role. We can delete the control plane, which again, there is a fairly significant cost to the control plane if it's left running. Now the Cloud9 instance, if that's something that you wanted to keep running so that you have the configuration and your AWS account is still in the free tier, the Cloud9 instance is running on a T2 micro, so it shouldn't actually cost you money to keep that running. But regardless, we are going to spin that down just so that there's no overarching cost, and the Cloud9 stack will spin down the stack for the Cloud9 instance itself once it gets to that point in the deletion because they're linked. So apologies that Kubernetes decided it didn't want to play. I'm going to need to go and find out whether anyone else has actually complained about that machine image, but that's a rough overview of, if you're interested in, you know, some of the security tools that people don't often use on Kubernetes, that's a rough overview of them. You've seen Chekhov actually working. You've seen some of the tools, you know, you've seen things like installing kubectl, actually how you would install tools like Sonar Cube, Falco, configuring Falco, running Kubebench. And so hopefully if any of you do work in organizations with Kubernetes, you can take some of these for a test drive. If you don't work in organizations that run Kubernetes and you're interested in it, there's definitely a lot to learn out there about it and how it works. So I would recommend probably looking as well at some of the basic tutorials on Kubernetes security. The people who maintain Kubernetes actually publish one themselves. And the Kubernetes documentation, surprisingly enough, is really comprehensive. So if you want to learn about it, that's where I'd go. Yeah, it is a massive amount of information to parse, Andre. And the thing that I've realized, and I'm kind of glad I did, considering that EKS failed on me, I cut a massive amount of information out of this when I was workshopping it for the first time, because there is just so much that you can get in terms of obscure security. Like even setting up an Nginx ingress to actually test Sonar Cube, if you don't have a cluster that has all of that established, that in and of itself can be an entire job. Going through Sonar Cube results can be an entire job. At some point, I would really like to redo this and actually do it as a whole day, because I think there's just so much in here that there's so much you can do with it. I really think, you know, I was trying to sort of limit it to 1.5, 2 hours, and I really think it's very difficult to give all of it justice in that time frame. It's an exceptionally complex topic, and and hopefully I've parsed it well enough that, you know, you've scratched the surface a bit. And if you're interested in this, you know where to go now to actually play around with it.
Yeah, well, thank you very much, Dawn. I think that was quite good, and it's very well structured as well in terms of static and runtime and all the other things. You also mentioned some of the non-obscure ones like the image scanning, etc. So it was lovely. I don't know about anybody else, but I really enjoyed it. Not that my cup of tea security, but still you put it in a really nice way so we can enjoy the overall topic.
And what I'll probably do this weekend, I will try and work out what the issue with that node was. If people are interested in it, I might look at actually doing this as a full day one, so that you get more time to play around with things. If we could find someone who'd give us AWS credit, you know, someone who'd be willing to sponsor the AWS credit so everyone can have a really good go at this, I might look at doing it as a full day on a weekend at some point, because it's just such a dense topic. There's so much we could go through here.
I'll take that one, and then possibly coordinate something like a game day.
Yeah,
we can try and change the. All right, let's talk about that one later without making these people more anticipate the next thing. There's one more question over here, Ahmed, before we close. I guess, what CI/CD tool do you recommend to use with the containers and Kubernetes clusters? I think I know an answer, but I'll let you.
Well, you probably know that my answer to that is it depends.
Exactly.
Because the thing about CI/CD tools is, depending on what you want to do and how you want to do it, there's just such a great variety out there. Like, if you want to run, you know, if you're in a large enterprise somewhere, you might choose to manage the whole thing yourself, which means you're probably looking at something like Jenkins. You might want to just shove it off on someone else. And then you're looking at, you know, GitHub Actions, Azure Pipelines. Circle CI is another one that's really common that does just the builds. The kind of the one that seems to be really common in the sort of intermediate space, which is basically you get the provider to manage access for you and you spin up the agents, is BuildKite, which is actually originally based in Australia. So I think there's no one correct answer to that. It really depends on, you know, is it a personal project? Is this for a big enterprise? What do you use already? You know, are you using 20 different tools? Are you using one? There's so many things that, I mean, we could do a whole workshop on CI/CD tools for AWS as well, probably. Yeah. But it would probably cost us way more money than we want to spend as interested hobbyists. But yeah, I would say it depends. Ask around, ask what people are using, for the type of situation that you want to use it in, and that will give you a fairly good idea of what you're probably looking at. I will admit, the two that I have a soft spot for are Azure Pipelines, because it's so easy to use out of the box and the UI doesn't give me headaches. And more, I do like BuildKite for being sort of the only one that's in that intermediate space where they manage all of the access, but you manage, you know, how you want to configure your agents, how you want to actually run things. I think the people who founded BuildKite had a really good idea with that one, because before BuildKite, most of the tools that were really commonly in use were one or the other. Either you managed everything, or it was really hard for you to manage any of it.
Yeah, I think my personal experience with GitLab is very nice as well, in terms of small to medium companies.
Yeah,
you can actually install on your machine. You can manage yourself, or you can use a SaaS provider. It also comes with the issue tracking, container registry. So it's kind of a full package for small to medium. But again,
while I was doing this workshop, I have actually played around. I played around with hosting my own GitLab instance just so I could say I've done it. I think I'm going back to GitHub now, because as you would see, if you look at the repository push, I pushed it up to GitHub like half an hour before because I'd forgotten that I hadn't already been developing it on GitHub. I mean, it had the advantage that I could sort of give access to a couple of people who were doing a bit of testing for me, you know, over the past 2 weeks. But yeah, GitLab is kind of an interesting one, and I've never used it just because, you know, it is quite linked into the GitLab ecosystem, but it is one that I've heard a lot of good things about. And I think in the same vein, if you're very much in the GitHub ecosystem, GitHub Actions is really getting to a level of maturity that now where it's quite good.
Yeah.
So, you know, if you're happy with the vendor lock in there and you're using one of those providers already for your Git, I do think both of their CI/CD offerings are a compelling way to go if you're already with that vendor.
All right, so let's not diverge from already complicated topic to another one. Unless you want to say any more, Dawn, I'd like to close off with thanking you.
No, I think that's good. I'm conscious that, you know, online it's really hard to sit through the whole 2 hours because we're all just exhausted from everything at the moment. So.
Believe it or not, you kept the audience engaged. I was looking at the numbers, nobody left. They still didn't. So I guess I'm going to be the reason for them to run away. But quick updates from our end. Again, please reach out to us, to myself, to Dawn, if you want to volunteer in any way possible. There is no, I can't do this, can I help? There's always a way to help. So just reach out if you have some spare time. We will post the video as soon as it's ready. So you will be able to watch it on your time. GitHub repository is also there, also in the Slack channel, as well as on our meetup group, so you can go at your own pace. But I always recommend you to get registered to our Slack channel, because then you can reach out to us faster, and you can get the updates faster.
See if I can grab the invite link and just stick it in.
Yeah, that would be good.
I don't think I actually have the invite link at my fingertips.
I'll find out.
Yeah.
But overall, please, even if you can't do anything, just spread the word so people can join our meetup group, and then we can be a larger, bigger, happier bunch as we go. I can see Gary is here, one of our organizers. Paul was here, one of our organizers, but just reach out, go to Slack, and then send a message. One of the organizers will reach out and then try to help you as much as possible.
Yeah, I would like to add a little bit, Dawn.
Yes,
Dawn, thank you for Dawn for this very good presentation. So for next month, we will have Gerald Bachmer from Sydney. He is AWS ambassador, and he will present us with AWS guardrail. So don't miss the opportunity next month. Thank you.
Excellent. So we are
looking forward to that. Thank you.
Yeah.
Thank you. Hey, you're still there.
It's good. That is actually one more thing that I'd like to encourage. If there's something that you're interested in, there's something that you've been playing around with on AWS, something that you would like to share, we have had like AWS ambassadors come and give presentations, but sometimes the best presentations that we have are from people who haven't presented a whole lot before, who've just found something that they're interested in and can turn it into a workshop for others. So if you do find yourself often going down rabbit holes in AWS, we are happy to help you put something together so that you can actually give it to the group if you want. If you want to get more confidence with presenting, if you found something that's really interesting and you want to show people how it works, then get in touch with us and we will, we can look at helping you out to actually set something up so that you can hopefully teach everyone else things they might not know about AWS.
Excellent. All right. Thank you very much again, guys. I'm dropping off and see you next time.